Welcome children. As now we are aware of what factorial notation is and how it is to be solved, let us take some questions based on factorial notations. Like, see the first example. It says find the value of 8 factorial minus 7 factorial over 6 factorial. Now we are going to simplify it. As you can see, 8 factorial can be written as 8 into 7 factorial, and keeping this 7 factorial as it is and the denominator 6 factorial as it is. You can see from the numerator 7 factorial can be taken common and we are left with 8 minus 1. Now this 8 minus 1 provides us 7, and this 7 factorial over here can be expanded and written as 7 into 6 factorial. So 6 factorial and 6 factorial gets eliminated and we are left with 7 into 7, that is 49. Let us see another one. We have to find the sum of 1 over 8 factorial, 1 over 9 factorial and 1 over 10 factorial. So if you look at all these three denominators, you will see 8 factorial is the smallest amongst these three. So we are going to expand 9 factorial and 10 factorial up to 8 factorial. So keeping 1 over 8 factorial as it is and then writing 9 factorial as 9 into 8 factorial. So the second term is 1 over 9 into 8 factorial. In the same way, the last term, which is 1 over 10 factorial, can be written as 1 over 10 into 9 into 8 factorial. And now you can see we have 8 factorial common in the denominator. And these are the terms we are left with: 1 plus 1 over 9 and plus 1 over 90. So taking the LCM, you can see the LCM will be 90, which I have written as 10 into 9, which is also getting multiplied with 8 factorial. Now when we take LCM over here, this 1 multiplies with 90, this 1 will multiply with 10 and this remains 1, and 90 is multiplying with 8 factorial. That 90 I have written as 10 into 9. Now let us simplify it further. You can see 90 plus 10 is 100, plus 1 gives us 101, and the denominator, if you see, it is expanded form of 10 factorial. So this is how the sum can be denoted. Now taking another one, see this. It is n plus 3 factorial over n factorial. So n plus 3 is greater than n. So we are going to expand n plus 3 factorial. So while expanding it, you will be writing the natural number preceding it. So the natural number just 1 less than n plus 3 will be n plus 2, and the one less than it will be n plus 1, and the one less than it will be n factorial. So in decreasing order it gets expanded, and we stop at n factorial. We don't further expand it because we already have n factorial in the denominator. So these two get eliminated, and what are we finally left with? The result is n plus 3 into n plus 2 into n plus 1. This is how we can even get rid of the factorial. Okay. Now see another one. This is product of some natural numbers given to us. We have to convert it into factorial notation. Now for factorial notation, we should have product of natural numbers starting with 1. But if you look at this product starts with 4. So three natural numbers are missing. That is product of 1 into 2 into 3. So what we do, we multiply the numerator by 1 into 2 into 3, and we also divide it by 1 into 2 into 3. So whatever is multiplied can be divided. Now we look at the numerator once more. See, this is consecutive. This is product of consecutive natural numbers beginning with 1. So 1, 2, 3, 4 up to 11. So this is expanded form of 11 factorial. That means the numerator is denoting 11 factorial. Can we convert the denominator also in terms of factorial? So we see it is product of 1 into 2 into 3. So it can be reduced to 3 factorial. So this is how the given product gets converted into factorials. Okay. Let us take another one. This we will try to convert it into factorials. Again look at the product. There are some numbers which are missing. These are product of consecutive odd natural numbers starting with 1. Okay, so I'm going to insert the missing even numbers, and whatever you will multiply in the numerator, the even number, with the same it needs to be divided. So you can see the numerator now we have written as product of 1 into 2. So this 2 is extra which is multiplied. Then this 4, then this 6. So all the even numbers we have inserted. So the product is 1 into 2 into 3 into 4 into 5 into 6, 2n minus 1, and the even number next to it is 2n. Okay, you can see now this is product of consecutive natural numbers beginning with 1. And what is the highest natural number here? It is 2n. So the product in the numerator reduces to 2n factorial. Now see the denominator. Whatever was multiplied in the numerator is multiplied in the denominator also. Now when we look at all these very carefully, we see they all can be written as multiple of 2. 2 is 2 into 1, 4 is 2 into 2, 6 is 2 into 3, 2n is 2 into n. So if you see, these are n numbers getting multiplied and each is a multiple of 2. So if I separate this 2 from each of the product, then how many times we are multiplying these two? You will see the 2 gets multiplied n number of times. So the product of 2, this 2, then this 2 till the last one comes out to be 2 to the power n. And what are the leftover terms in the product? We are left with 1 into this 2 into this 3 till into this n. So this is what it is reduced to now. And when you look at the product in the bracket, you will see it is denoting the product of first n natural numbers. So we can write it as n factorial. Fine. So see how the product was converted into factorials. Now proving few of these. In the first one, they are asking us to show that the product of this entire expression, this will reduce to n factorial over n minus r factorial. So just have a look at this. N minus r plus 1 as it is. N factorial also we have written as it is. Now look at this denominator. It is factorial of n minus r plus 1. So I am going to expand it. Okay. So the consecutive natural number 1 less than it, the one which is preceding it, will be 1 less than this. So if it is n minus r plus 1, when we expand it, the very next one will be 1 less than it. So from this, if you subtract 1, the preceding natural number will be n minus r. And we stop here only, we don't further extend it. Okay, so this is written as n minus r plus 1 into n minus r factorial. So what do we see now? This is independent of factorial. This is just a number which gets cancelled out with the same numerator. And what are we left with? N factorial over n minus r factorial. That is the right hand side. Okay. In the same manner, let us check for the next one. Keeping the first term of the left hand side as it is and moving on to the second term, you can see numerator I have written in the same way, but I have expanded the denominator. How will you decide which term to be expanded? See, these are two denominators. So out of these two, you will see which one is the greater one. That is the one you are going to expand till you don't reach the other term given in the denominator. Okay. So n minus r we are expanding, n minus r factorial. So it can be written as n minus r into factorial of a natural number which comes before this. So the one which will come before this will be 1 less than this. So it is n minus r into n minus r minus 1 factorial. Now this is independent of factorial. Now you look at the entire expression. You will see from the numerator we can take n minus 1 factorial common. In the denominator we can take n minus r minus 1 factorial common. And what are we left with? From here we are left with 1. From here we are left with r over n minus r. So over here we are going to take LCM. So keeping this part as it is and taking LCM here, we find this r and r gets cancelled out. So what is the numerator now? I will just rearrange the terms. The numerator is n into n minus 1 factorial. Same we will do in the denominator. It is n minus r into n minus r minus 1 factorial. Let us see, can we compile it? n and n minus 1 are consecutive natural number and n is 1 more than n minus 1. So this product can be written as n factorial. Same follows in the denominator. See these two, n minus 1 is a natural number which is consecutive to this. It is 1 greater than n minus r minus 1. So these are consecutive natural numbers and n minus r is the one which succeeds n minus r minus 1. So the product of n minus r with n minus r minus 1 factorial will be actually n minus r factorial. You can see this is the required right hand side. Then moving on to another type. Over here an equation is given where they are saying x is a natural number and we have to find the value of x. You can see these two terms are getting multiplied. So we'll compare all the x factorial terms here and we will see which two are related and where one can be converted to other. Now you compare these two, they are of the same type. Out of 2x plus 1 and 2x minus 1, 2x plus 1 is greater. So I am going to expand 2x plus 1 factorial. In decreasing order, see it expands 2x plus 1, then the one before it will be 1 less than it, that means 2x, and after that 2x minus 1. So here we stop, so put factorial. We are not expanding it further. So done with this part. Now comparing x plus 2 and x minus 1, you will see x plus 2 is larger than x minus 1. So we are going to expand the factorial of x plus 2. Let us see what it comes out to be. We get x plus 2, then it is x plus 1, then it is x, and then we stop at x minus 1 factorial. Okay, because same is available in the numerator of other term. So after expanding these, we see 2x minus 1 factorial gets eliminated, x minus 1 factorial gets eliminated, and this is what we are finally left with. You can see we don't have factorial anywhere now. Okay, so 2x plus 1 is multiplying with 2, which is further multiplying with x. So these are all independent terms. You can see this x can be cancelled out with the x in the denominator. Now go for cross multiplication and get a resulting quadratic equation. 2 into 5 will be 10. So 10 is multiplying with 2x plus 1. In the same way, this 3 multiplies with the product of these two, which is x square plus 3x plus 2. Further simplifying it, both the sides of the equation, we finally get a quadratic equation 3x square minus 11x minus 4. You can see it can be solved by splitting the middle term. So minus 11x can be written as minus 12x plus x. Now taking 3 common and x common from the first two terms, we are left with x minus 4. In the later part, you can take x common and we are left with x minus 4 equal to 0. So what are the two factors available? One is 3x plus 1, another is x minus 4. This product is 0. Okay, so we get two values of x here. So this implies if I put x minus 4 is equal to 0, we get x is equal to 4. And if we put 3x plus 1 is equal to 0, what do we get? X is equal to minus 1 by 3. Are we going to keep that value? So we get back to the given conditions. It says x belongs to n. So the other value of x which will be obtained cannot be taken. Okay, so x is 4 as x cannot be equal to minus 1 by 3. So what is the possible value of x here? It should be 4. So this equation is satisfied if x is equal to 4. Now children, taking another one. See, we are given an equation and using this we have to find the value of n. Again, you look at the terms including factorial. This is n plus 1 factorial. This is n minus 1 factorial. If you compare, the natural number n plus 1 is greater than the natural number n minus 1. So while simplifying this, we'll go for expanding n plus 1 factorial, which gives us n plus 1 into n minus 1 factorial. And on the right side, it is 12 times n minus 1 factorial. So you can see this gets eliminated. And this is what we are left with. You can expand it, convert it into quadratic equation, and then you can solve for n. But there is an alternative method to it. What kind of product is this? This is product of two consecutive natural numbers in the decreasing order. So can you write 12 as product of two consecutive numbers in decreasing order? See, we can write it as 4 into 3. Now from here we can equate the corresponding terms and get the value of n. So n plus 1 will be equal to 4, which implies n is equal to 3, or you can simply say n is equal to 3. If we equate n plus 1 is equal to 4, then also we get n is equal to 3, or you can directly write n is equal to 3. So this reduces our work. If you manage to break it into the same form as the left hand side, then the corresponding terms can be equated and the value can be easily obtained. Now taking another one, see over here we need to prove this. A bit of same kind we have done in one of the previous questions, if you can recall. See, we have to prove 2n factorial is this much. Okay, so we first go for expanding 2n factorial. So it will be 2n, then preceding term 2n minus 1, 2n minus 2. You can see it keeps on decreasing till it reduces to 1. So out of these 2n terms, if I count from here 1, 2, 3 till 2n. So these are 2n natural numbers. Out of these 2n natural numbers, n are even, n are odd. So I have separated the even and the odd numbers. So look at the even numbers, 2n, then 2n minus 2. Obviously we will get 2n minus 4, and then 6, 4 and 2. And these are the rest of the odd numbers. Now just compare it to the required right hand side. You will see this is needed. This entire term as it is needed. So we will do all simplification here and we'll keep this part as it is. So you look at all these again. You will see each term is a multiple of 2. 2n means 2 into n. 2n minus 2 means 2 into n minus 1. 4 means 2 into 2. 2 means 2 into 1. So you can see these are n terms which are multiplying, and each has got a 2 with it. Each is a multiple of 2. So if I separately multiply all these 2, you will see 2 is getting multiplied how many times? N times, because these are n terms. From each n term you have taken a 2 separately and all of these 2 are multiplied. Okay, then what is left in the product? In the product you are left with n. You are left with, here you are left with n minus 1. Obviously in the next term it will be n minus 2 and so on. See, here I am left with 2 and then it is 1. And the later part as it is 2n minus 1 till 5, 3, 1. Now let us wind it up. If you look at this part, look at the product. It is product of first n natural numbers. Okay, so it can be written as n factorial. Even the later part, you can write it as a product of 1 into 3 into 5 till 2n minus 1. And this is how we can obtain the right hand side. So children, by now you must have seen we have taken enough examples where we can deal with factorial notations and we can simplify them.